The morning of July 18th, 1943, Generaloberst Heinz Guderian stood in his headquarters at Rastenburg, East Prussia, studying intelligence reports from the Eastern Front. The papers spread across his desk contained claims so absurd he had initially dismissed them as clerical errors. American tank deliveries to the Soviet Union through the Lend-Lease program had reached 4,000 units per month, 4,000 tanks per month. Guderian commanded panzer forces for the entire Eastern Front. He knew tank production intimately. Germany's factories had produced fewer than 6,000 panzers in all of 1942. The Americans were supposedly delivering two-thirds of Germany's annual tank production every single month to just one ally. The numbers violated everything Guderian understood about armored vehicle manufacturing. Building a tank required precision machining, specialized armor plate, complex transmissions, gun systems with tolerances measured in thousandths of an inch. Each component demanded skilled workers, specialized tooling, and months of assembly time. Germany had spent 2 decades developing its panzer forces. The factories at Krupp, Henschel, and MAN represented the finest heavy machinery manufacturing in Europe. These facilities employed master craftsmen who had spent years learning their trades. German tanks were engineering marvels, each one a precision instrument of war. Yet German production had peaked at 600 tanks per month in early 1943, and that rate was straining every resource the Reich possessed. The Americans had entered the war with almost no tank production capacity. In 1939, the United States Army possessed fewer than 400 tanks total, most of them obsolete light tanks unsuitable for modern warfare. American tankers trained with trucks fitted with wooden gun barrels because actual tanks were too scarce for training exercises. Now, less than 4 years later, American intelligence suggested the United States was producing more tanks in a single month than Germany produced in an entire year. Guderian had seen American tanks. The M4 Sherman had appeared in North Africa in late 1942 during Operation Torch. German tank commanders reported fighting them at Kasserine Pass, at El Guitar, across Tunisia. The reports were consistent. The Sherman was adequate but not exceptional. It mounted a 75mm gun, effective but not devastating. Its armor was decent, not impenetrable. German Tiger tanks could destroy Shermans at ranges beyond 2,000 meters. German Panther tanks could penetrate Sherman armor from the front at 1,500 meters. Sherman crews had to close to within 500 meters for reliable kills against German heavy tanks. In a one-on-one engagement, German tanks were superior. Guderian knew this. Every panzer commander knew this. German tank doctrine emphasized quality over quantity. Each panzer was a superior fighting vehicle crewed by extensively trained soldiers who understood their equipment intimately. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Sherman appeared to validate German assumptions about American industrial philosophy. Americans built adequate equipment quickly, rather than excellent equipment slowly. That approach might work for rifles or trucks, but tanks were different. Complex armored fighting vehicles could not be mass-produced like automobiles, or so Guderian believed. The intelligence reports on his desk suggested otherwise. 4,000 tanks per month meant the Americans were building 130 tanks every single day. That was one Sherman completed every 11 minutes, 24 hours per day, 7 days per week. The calculation seemed impossible. Guderian requested verification from German intelligence officers. They confirmed the numbers. Photographic reconnaissance of American ports showed hundreds of tanks waiting for shipment. Intercepted communications referenced production targets that exceeded even the most alarming estimates. Captured American soldiers spoke casually about tank factories that operated continuously, producing vehicles faster than the army could train crews for them. Guderian understood what these numbers meant if they were accurate. Germany was losing the production war catastrophically. Not gradually, not by small margins, but by ratios that made tactical superiority irrelevant. A Tiger tank might destroy 5 Shermans before being knocked out. But if America produced 20 Shermans for every Tiger Germany built, The mathematics of attrition became unsustainable. The question that troubled Guderian was simple. How were they doing it? How had a nation with almost no tank production experience in 1939 become capable of producing more armoured vehicles than Germany, Britain, and the Soviet Union combined by 1943? The answer began not with military planners or tank designers, but with automobile manufacturers who had never built a military vehicle in their lives. In August 1940, while France burned and Britain stood alone, the United States War Department issued a request to American industry. The Army needed a new medium tank to replace the obsolete M2, which had been designed in 1938 and was already outclassed by German panzers. The specifications were straightforward. The new tank needed to weigh approximately 30 tons, mount a 75mm gun, have armour sufficient to stop German 37mm anti-tank rounds, travel at 25 miles per hour, and be reliable enough for sustained operations. Most critically, it needed to be producible in large numbers using American manufacturing methods. The Rock Island Arsenal in Illinois designed the T6 prototype using components from existing vehicles. The hull design came from the M2 tank. The suspension used a vertical volute spring system adapted from earlier designs. The transmission was a modified version of components already in production. The turret was new, designed to mount the 75mm gun in a fully rotating position. The first prototype was completed in September 1940. The Army tested it, requested modifications, and approved it for production in October 1940 under the designation M3. But even before the M3 entered full production, designers were working on improvements that would become the M4. The M4 Sherman incorporated lessons learned from early M3 production. The hull was welded rather than riveted in most versions, which was faster and created fewer weak points. The suspension was refined for better cross-country performance. The engine compartment was redesigned to accommodate multiple engine types because planners knew that no single engine manufacturer could produce enough power plants to meet projected tank production targets. This decision, using multiple different engines in what was otherwise a standardized design, revealed something fundamental about American industrial thinking. German tanks used purpose-built engines designed specifically for armored vehicles. The Maybach HL 230 engine that powered the Panther tank was a masterpiece of German engineering, but it could only be produced by Maybach. If Maybach's production capacity was maxed out, Panther production stopped. The Sherman used whatever engines were available. Continental radial aircraft engines, General Motors diesel engines, Chrysler multibank engines, created by welding 5 automobile engines together, Ford GAA V8 engines. 5 different engine types in the same tank design. German engineers considered this approach crude, unprofessional, a sign of American industrial backwardness. They were wrong. Using multiple engine types meant that Sherman production was never constrained by a single bottleneck. If Continental couldn't produce enough radial engines, Chrysler's multibank engines filled the gap. If Chrysler had problems, Ford's V8S kept production moving. The flexibility was deliberate, designed into the system from the beginning by engineers who understood that winning a war required building enough equipment, not perfect equipment. The first M4 Sherman rolled off the production line at the Lima Locomotive Works in Ohio in February 1942. Lima had never built a tank before. The company made railroad locomotives, massive steam engines that pulled freight trains across America. When the War Department contracted with Lima to produce Shermans, the company had to completely retool its facilities, train its workers, and learn tank production from scratch. The first Sherman took 6 months from the start of retooling to completion. The 10th Sherman took 3 months. By June 1942, Lima was completing 1 Sherman every 3 days. By December 1942, Lima was completing 1 Sherman every day. The company that had never built military vehicles was producing a tank every 24 hours, using workers who had never seen a tank before 1942. Lima was not exceptional. It was typical. The pressed steel car company in Pennsylvania had built railroad cars. They retooled for Sherman production and reached a production rate of 1 tank every 8 hours by mid-1943. The Pacific Car and Foundry Company in Washington state built logging equipment. They produced Shermans at a rate of 75 per month by late 1943. The Baldwin Locomotive Works in Pennsylvania built steam locomotives. They produced Shermans alongside their locomotive production using the same workforce. The Fisher Body Division of General Motors had built automobile bodies. They converted their facilities to Sherman production and became the largest single producer of the tank, building more than 11,000 Shermans before the end of the war. Every major producer shared common characteristics. None had built tanks before. All had experience with heavy machinery, structural steel, and precision machining from their peacetime industries. All adapted their existing manufacturing expertise to tank production rather than starting from scratch. And all achieved production rates that German intelligence analysts insisted were impossible. The technique that made this possible was the same technique that had revolutionized American automobile production 30 years earlier: modular assembly with interchangeable parts. Henry Ford had not invented the assembly line, but he had perfected it for automobile production. The Ford Model T was built from components that were manufactured to such precise specifications that any part would fit any vehicle. A cylinder head made in Ford's Highland Park plant in Michigan would fit perfectly on an engine block made in Ford's Rouge River plant in Dearborn. Workers didn't custom-fit parts. They grabbed pre-made components from bins and bolted them together in sequence as the chassis moved past on a conveyor. The Sherman used the same principle. The hull was divided into modules: lower hull, upper hull, turret, each built separately in different areas of the factory. The lower hull contained the suspension, the transmission, and the floor. This module was built on dedicated assembly fixtures that held everything in precise alignment. Workers installed the suspension components, the transmission, the final drive assemblies, and the floor plate. The completed lower hull moved to the next station. The upper hull contained the sides, front, and rear armor plates. This module was welded together in a dedicated welding area using jigs that ensured every angle and every dimension was identical to specifications. The completed upper hull moved to the lower hull assembly station, where cranes lifted it into position and welders joined the two modules. The turret was built in a separate area. The turret ring, the gun mount, the gun itself, the recoil mechanism, the sights, all assembled in sequence on turret-specific fixtures. The completed turret was tested to ensure the gun elevated and traversed properly, then moved to final assembly. This modular approach meant that multiple tanks could be in production simultaneously at different stages. While workers welded the upper hull for tank number 100, other workers installed the suspension for tank number 101, assembled the turret for tank number 102, and installed the engine for tank number 99. The factory operated as a synchronized system where every station had work in progress and completed components flowed continuously to the next stage. German tank production worked differently. Each Panzer was built as a complete unit from start to finish in a single location. Skilled workers built the entire tank, from welding the hull to installing the engine to mounting the gun. This craft production approach created beautiful machines, but it was slow. A Panther tank required approximately 150,000 man-hours from start to completion. That was 3,000 hours per tank if 50 workers built it together. Assuming 8-hour workdays, that was 375 days, 1 year to build a single tank using a dedicated team of 50 skilled workers. A Sherman required approximately 10,000 man-hours from start to completion using modular assembly methods. That was 1/15 the labor of a Panther. Even accounting for the Panther's heavier armor and more complex systems, the difference was staggering. American factories could build 15 Shermans using the same labor hours required for one Panther. This labor efficiency multiplied across the entire production system. Fisher Body employed 45,000 workers at its Grand Blanc, Michigan tank plant at peak production. Those workers built 175 Shermans per month in mid-1943. That increased to 250 per month by late 1943, then to 300 per month by early 1944. The production rate kept climbing not because more workers were added, but because workers became more efficient through repetition and because manufacturing processes were continuously refined. A worker who installed transmissions installed 50 transmissions per week. After 3 months, that worker could identify problems by feel, could complete the installation in half the time, could train new workers faster than experienced supervisors. Repetition created expertise without formal training. The Sherman's modular design made this possible. Workers didn't need to understand how a tank functioned. They needed to understand how their specific component functioned and how to install it correctly. A worker who welded hull seams didn't need to know how the gun sights operated. A worker who installed engines didn't need to understand armor metallurgy. Specialization increased speed. German Panzer production required generalists who understood the entire vehicle. This created vulnerabilities. If a master tank builder was killed in an air raid or conscripted into combat service, his expertise was lost. Training a replacement took months or years. American Sherman production required specialists who understood one task. If a worker was lost, training a replacement took days or weeks. The system was resilient because it did not depend on master craftsmen. The modular approach also simplified logistics. A Sherman transmission was identical across all production variants. Any transmission would fit any Sherman, regardless of which factory built it. If the Chrysler Detroit Arsenal had surplus transmissions and the pressed steel car company needed transmissions, they shipped them. Parts were interchangeable, not just within a factory but across the entire production system. German tanks used custom-fitted components. A transmission built for Panther No. 1043 at the MAN factory in Nuremberg would not necessarily fit Panther No. 1044, built at Daimler-Benz in Berlin. The tolerances were tight, the craftsmanship was excellent, but interchangeability was limited. This created supply problems. When Panthers broke down in combat, replacement parts had to come from specific factories. If those factories were bombed or if transportation was disrupted, the tanks sat immobile, waiting for parts that might never arrive. Sherman parts came from dozens of factories, and any part would fit any tank. This meant field maintenance was faster, supply chains were shorter, and damaged tanks could be cannibalized for parts that worked in any other Sherman. The strategic implications were profound, but German intelligence missed them because they were looking at the wrong metrics. German analysts counted tanks. They knew Germany produced approximately 600 panzers per month in early 1943. They estimated American production at perhaps 1,500 tanks per month based on reported sightings and captured documents. Those estimates were wrong by a factor of 3. America produced 4,700 tanks in January 1943. 4,000 of them were Shermans. The actual production rate was not 1,500 per month. It was 4,700 per month, and it was accelerating. By April 1943, American factories produced 5,700 tanks. By July 1943, when Guderian sat in his headquarters staring at reports he couldn't believe, American production had reached 6,500 tanks per month. Of those 6,500, approximately 4,000 were Shermans. The rest were light tanks, tank destroyers, and specialized variants. 4,000. Shermans per month meant 133 per day. That was one Sherman completed every 11 minutes around the clock. The Germans called it propaganda. They assumed the Americans were inflating production numbers to intimidate the Axis powers. German intelligence reports from mid-1943 stated that American tank production claims were exaggerated by a factor of 2 or 3 to create the impression of overwhelming industrial might. The reports concluded that actual American tank production was probably around 2,000 per month, significant but manageable. The reports were catastrophically wrong. American tank production in 1943 totaled 47,000 tanks, 29,200 of them were Shermans. Germany produced 12,000 tanks of all types in 1943. The ratio was approximately 4 American tanks for every German tank, but the ratio understated American advantage because German production included light tanks, assault guns, and tank destroyers that were counted as tanks but were not equivalent to medium tanks like the Sherman or heavy tanks like the Tiger. If the comparison was limited to medium and heavy tanks, American production exceeded German production by ratios approaching 6-1. The Soviet Union produced 24,000 tanks in 1943, approximately double German production. Britain produced 8,000 tanks in 1943. Total Allied tank production in 1943 was approximately 79,000 tanks. Total Axis production was approximately 14,000 tanks, with Germany producing 12,000 and Italy and Japan contributing the rest. Allied advantage was roughly 6-1, and America alone was producing more tanks than the entire Axis combined. These numbers were known to American planners in real time. The War Production Board tracked output daily from every factory. They knew exactly how. Many Shermans were completed each week, each month, each quarter. They published the numbers in internal reports that circulated among government officials and military commanders. The numbers were not classified because American intelligence believed German intelligence would never believe them anyway. They were correct. Guderian looked at his intelligence reports in July 1943 and concluded they contained errors. 4,000 tanks per month was impossible. He filed the reports and requested better intelligence. He would spend the next 2 years watching those impossible numbers prove accurate as American Shermans appeared in overwhelming quantities on every front where American forces operated. The first large-scale encounter between Shermans and German panzers occurred in North Africa during the Tunisia campaign in early 1943. German tank commanders filed detailed reports describing the new American tank. The Sherman was mechanically reliable, unlike many American weapons that arrived in combat zones with teething problems. It was faster than German medium tanks, capable of 25 miles per hour on roads compared to the Panzer IV's 24 miles per hour. Its suspension handled rough terrain well. The crew compartment was spacious compared to German tanks, which improved crew efficiency during extended operations. These were professional assessments, noting both strengths and weaknesses. The weaknesses were significant. The Sherman's 75mm gun could not penetrate the frontal armor of a Tiger tank at combat ranges. The Sherman's armor could not stop an 88mm round from a Tiger at any range where the Tiger could achieve hits. In direct confrontations, Tigers dominated. German after-action reports from Tunisia documented this superiority. One Tiger could engage and destroy multiple Shermans before the Shermans could close to effective firing range. The kill ratios favored German, heavy tanks substantially. At the Battle of Sidi Bou Zid in February 1943, German Tigers destroyed 50 American tanks while losing only 3 panzers. Similar ratios appeared in reports from Kasserine Pass, Speitle, and other engagements across Tunisia. German tank commanders concluded the Sherman was vulnerable but numerous. American units that lost 10 tanks one day would return with 15 tanks the next day. Destroyed Shermans were replaced faster than German intelligence thought possible. Initially, German commanders assumed the Americans were pulling tanks from strategic reserves. They expected American tank numbers to decline as those reserves depleted. The numbers increased instead. More Shermans arrived every week. By April 1943, American armored divisions in North Africa fielded more tanks than they had started with in November 1942 despite heavy combat losses. The explanation was simple but difficult for German commanders to accept. American factories were producing replacement tanks faster than German forces could destroy them. The pattern repeated in Sicily during July and August 1943. German defenders knocked out dozens of Shermans. The Americans brought more. In Italy, during the autumn of 1943, German panzer units achieved favorable kill ratios. It didn't matter. American tank strength remained constant because replacements arrived continuously from factories in the United States. By late 1943, German intelligence had revised their estimates of American tank production upward, but still underestimated the actual numbers. Reports circulated in Berlin suggesting American production might reach 3,000 tanks per month, double the previous estimate, but still only 60% of actual production. The systematic underestimation occurred because German analysts applied German production standards to American industry. In Germany, increasing tank production required building new factories, training new workers, and securing additional raw materials. All three were constrained. Germany could not build new factories fast enough because construction materials were scarce and labor was needed elsewhere. Germany could not train new workers fast enough because skilled craftsmen were being conscripted into military service. Germany could not secure additional raw materials because Allied bombing was disrupting transportation and Allied submarines were sinking merchant ships carrying critical imports. German production was hitting ceilings that seemed immovable. German analysts assumed American production faced similar constraints. They were wrong. American tank production in 1943 was not constrained by factories, workers, or materials. The United States had converted automobile factories to tank production, and those factories had excess capacity. Fisher Body's Grand Blanc plant could have produced more Shermans than it actually built if the Army had ordered them. The Chrysler Detroit Arsenal, which was purpose-built for tank production, operated at approximately 80% capacity in 1943 because the Army didn't need more tanks than were being produced. American production was limited not by industrial capacity but by strategic decisions about how many tanks were needed. This was incomprehensible to German planners who were desperately trying to increase production despite maxed-out factories. American factories had workers, millions of workers. The unemployment rate in the United States in 1939 had been 17%. Over 8 million Americans were unemployed. By 1943, unemployment had dropped to 1%. Those workers had moved into defense factories, including tank plants. The Fisher Body plant employed 45,000 workers. Most were women. Most had never held industrial jobs before the war, but they learned quickly, because the work was broken down into simple, repetitive tasks. A worker who installed machine gun mounts installed the same component on tank after tank, dozens per shift. After a month, the task became automatic. After 3 months, the worker could train others. The learning curve was steep because the tasks were designed to be learnable. American factories had steel, enormous quantities of steel. The United States produced 81 million tons of steel in 1943, more than Germany, Britain, and the Soviet Union combined. American steel mills operated at full capacity, producing armor plate, structural steel, gun barrels, tank tracks, everything needed for tank production without rationing. If a Sherman hull was incorrectly welded, the factory scrapped it and built another one. The wasted steel was insignificant compared to total production. German factories couldn't afford to scrap incorrectly welded hulls. Steel was too precious. Mistakes had to be cut out and repaired, which took time and slowed production. American factories optimized for speed. German factories optimized for material conservation. In wartime, speed won. The production methods that created this output were studied carefully by German intelligence once they accepted the numbers were real. Captured American training manuals described Sherman assembly procedures. German engineers analyzed the manuals looking for weaknesses they could exploit. Instead, they found a production system more sophisticated than Germany's, despite its apparent simplicity. The Sherman was designed for manufacturing, not just for combat. Every component was designed to be built quickly using available machine tools and available workers. The turret ring, which allowed the turret to rotate on the hull, was a critical component requiring precision machining. German turret rings were machined from solid steel forgings, which required massive lathes and highly skilled operators. The Sherman turret ring was built from multiple segments that were machined separately, then welded together. This approach was faster and required less sophisticated equipment. German engineers initially dismissed it as crude, but testing captured Shermans revealed the welded turret rings performed just as well as German machined rings. Crude did not mean inferior. It meant manufacturable at scale. The transmission was another example. German tank transmissions were precision devices with dozens of gears, synchros, and bearings machined to extremely tight tolerances. They were mechanical marvels, smooth, efficient, powerful, but extraordinarily difficult to manufacture. Each transmission required hundreds of machining operations by skilled workers using specialized equipment. The Sherman used a transmission adapted from commercial trucks with modifications for increased power. The tolerances were looser, the shifting was less refined, but the transmission was reliable and could be manufactured in enormous quantities by workers with minimal training. American designers had made a conscious choice. They sacrificed refinement for producibility. German designers made the opposite choice. They sacrificed producibility for refinement. In peacetime, German choices created superior vehicles. In wartime, American choices created sufficient vehicles in overwhelming numbers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The manufacturing differences extended to quality control. German tank production emphasized perfection. Every component was inspected multiple times. Tolerances were checked with precision gauges. Welds were X-rayed to detect internal flaws. Tanks were tested extensively before delivery to ensure they met specifications. This approach produced tanks that were mechanically excellent, but it was slow and caught problems late in the production process. If a hull failed final inspection after weeks of work, the entire production schedule was disrupted. American tank production emphasized process control rather than final inspection. Instead of inspecting finished products, American factories controlled the manufacturing process to prevent defects. Welding procedures were standardized. Workers were trained to specific techniques. Jigs and fixtures held components in precise alignment during assembly. Statistical process control, a technique developed by American quality engineers before the war, monitored production continuously. If measurements started drifting out of tolerance, the process was stopped and corrected before defective parts were produced. This approach, focusing on preventing defects rather than catching them, was faster and more efficient. Defect rates were actually lower in American factories than German factories despite less extensive final inspection. The Sherman gained a reputation for reliability because American manufacturing processes were inherently stable. Tanks came off the production line ready for combat without extensive break-in periods or immediate maintenance. German tanks often required significant work after delivery because final assembly had been rushed or because components had been imperfectly fitted. The stereotype of German engineering excellence and American industrial crudeness was backwards. American industrial processes were more sophisticated. They just looked simpler. By 1944, the production gap had widened catastrophically. American tank production reached peak output. In February 1944, American factories completed 2,100 Shermans. That was 70 Shermans per day. In March, 2,300. In April, 2,200. The monthly totals remained consistently above 2,000 Shermans throughout 1944. Total Sherman production for the year was 17,186 tanks. Germany produced 19,000 tanks of all types in 1944, but that number included thousands of assault guns and tank destroyers that were classified as tanks but were not equivalent to the Sherman's capabilities. Actual German medium and heavy tank production was approximately 9,000 vehicles, including 3,700 Panthers and 600 Tigers. America produced twice as many Shermans as Germany produced total armored vehicles, and America was simultaneously producing thousands of light tanks, tank destroyers, and armored vehicles for British and Soviet forces. The Fisher tank arsenal alone produced more Shermans in 1944 than Germany produced Panthers and Tigers combined. One factory in Michigan, operated primarily by workers who had never built tanks before 1942, outproduced the entire German Panzer industry. German tank commanders on the Eastern Front and in France faced the consequences of this production disparity. After the Normandy invasion in June 1944, American armored divisions flooded into France. Each armored division fielded 192 Shermans at full strength. The United States deployed 16 armored divisions to Europe by the end of 1944. That was over 3,000 Shermans in divisional units alone, not counting separate tank battalions attached to infantry divisions or tanks held in reserve. German panzer divisions fielded approximately 120 tanks at full strength when they had full strength, which was rare. Most German panzer divisions in France during the summer of 1944 operated at 50 to 70% strength because replacement tanks were not arriving fast enough to cover combat losses and mechanical breakdowns. A full-strength German panzer division with 120 tanks faced American armored divisions with 192 tanks. The numerical disadvantage was compounded by the fact that American divisions could replace losses within days, while German divisions waited weeks or months for replacements. The operational implications were profound. American commanders could accept tactical losses that would have been unthinkable for German commanders. If an American armored division lost 20 tanks capturing an objective, those 20 tanks were replaced within a week. The division returned to full strength and continued operations. A German panzer division that lost 20 tanks was effectively combat ineffective for weeks. The division had to be pulled from the line and rebuilt. By the time it returned to combat, it had lost weeks of operational time. This asymmetry in replacement rates meant American armored forces could sustain offensive operations continuously, while German panzer forces operated in short, intense bursts, followed by long reconstruction periods. The strategic initiative shifted permanently to the Allies because only the Allies could maintain continuous pressure. German commanders adapted their tactics to cope with overwhelming American tank numbers. They could not match Sherman numbers, so they focused on achieving favorable kill ratios through superior tactics and superior heavy tanks. The Tiger and Panther were designed to kill multiple Shermans before being destroyed. In many engagements, they succeeded. A well-positioned Tiger could destroy 6 or 7 Shermans in a single engagement. A Panther platoon in good defensive terrain could stop an entire American tank company. But favorable kill ratios did not change the strategic calculus. If a Tiger destroyed 7 Shermans before being knocked out, and if America produced 7 replacement Shermans for every Tiger Germany produced, the exchange was strategically neutral. In reality, America produced approximately 25 Shermans for every Tiger. The mathematics of attrition favored America so heavily that tactical skill became largely irrelevant. Otto Carius, a German Tiger commander with over 150 tank kills on the Eastern Front, described the futility in his post-war memoir. He recounted an engagement near Malinava in Estonia in July 1944, where his Tiger destroyed 11 Soviet T-34 tanks in 15 minutes. It was a textbook example of German tactical superiority. The Tiger's 88mm gun had destroyed 11 enemy tanks at ranges where the T-34 seconds could not effectively return fire. Carius's crew escaped without damage. 2 days later, Carius encountered another Soviet tank column in the same area. It contained 20 T-34 seconds. His Tiger destroyed 8 before mechanical problems forced a withdrawal. 4 days after that, he encountered 30 T-34 seconds. The Soviets were receiving tanks faster than his Tiger could destroy them. Eventually, Carius's Tiger was knocked out not by superior Soviet tactics, but by being overwhelmed by numbers. His crew could not physically engage fast enough. The same pattern occurred in France. Kurt Knispel, Germany's highest-scoring tank ace with 168 confirmed kills, fought in Normandy with a Tiger unit in July 1944. His Tiger destroyed multiple Shermans in engagement after engagement. By August, his unit had been pushed back to Falaise, despite achieving kill ratios that exceeded 10-1 in their favour. They ran out of ammunition, out of fuel, and out of room to manoeuvre. The Shermans kept coming. German tactical superiority could win individual battles. It could not win the campaign because American industrial superiority ensured the Shermans kept arriving no matter how many were destroyed. By September 1944, German commanders stopped reporting kill ratios in their after-action reports. The ratios were tactically favorable but strategically meaningless. What mattered was whether objectives were held or lost, and objectives were being lost because German forces were being ground down by attrition they could not replace. The German army began 1944 on the Eastern Front with approximately 2,500 operational tanks. By December 1944, despite producing 19,000 armoured vehicles during the year, German operational tank strength had declined to approximately 1,500 tanks. 22,000 tanks had been lost, destroyed in combat, abandoned due to mechanical failure, or captured. Production had replaced only 19,000, leaving a net loss of 3,000 tanks. Meanwhile, Soviet tank strength had increased. American Lend-Lease deliveries, plus Soviet domestic production, exceeded Soviet losses. The Red Army began 1944 with approximately 5,000 tanks and ended the year with approximately 8,000 tanks despite suffering enormous losses during offensives across Ukraine, Belarus, and Poland. The production disparity was destroying Germany's ability to wage mobile warfare. Panzer, divisions that had once struck deep into enemy territory, now fought desperate defensive battles trying to slow Allied advances. The operational flexibility that had characterized German armored doctrine in 1940 and 1941 was gone. There were not enough tanks to conduct mobile operations. There was not enough fuel to move the tanks that existed. There were not enough replacement crews for tanks that were lost. The entire system was collapsing under the weight of industrial inadequacy. Albert Speer, who became Minister of Armaments and War Production in February 1942, had worked desperately to increase German production. He rationalized factory layouts, reallocated labor, streamlined supply chains, and implemented American-style production techniques where possible. His efforts succeeded in increasing German tank production from 600 per month in early 1942 to over 1,600 per month by late 1944. That increase represented a Herculean effort. Speer had tripled tank production in less than 3 years despite Allied bombing, despite labor shortages, despite material shortages. It was an extraordinary achievement. It was also completely insufficient. While Speer tripled German tank production, American tank production had increased from fewer than 100 tanks per month in early 1941 to over 4,000 Shermans per month by 1943. The American increase was 40-fold compared to Germany's 3-fold increase, and American production was achieved with far less disruption to civilian production. German factories operated under constant air attack. Workers spent hours in bomb shelters. Transportation networks were degraded by bombing. Raw materials arrived irregularly because trains were being destroyed. American factories operated in complete safety. No bombs fell on Detroit, on Lima, on Pittsburgh. Workers showed up for shifts on time. Materials arrived on schedule. The factories ran at peak efficiency without interruption. This safety factor multiplied American advantages. A factory operating at 90% efficiency because of air raid disruptions produces dramatically less than a factory operating at 98% efficiency in complete safety. The cumulative effect over 3 years was enormous. Speer later calculated that Allied bombing reduced German armaments production by approximately 30% compared to what Germany could have produced without bombing. That 30% reduction applied to a production base that was already 1/5 the size of American capacity. Germany was producing 70% of a much smaller baseline. America was producing 100% of a vastly larger baseline. The strategic bombing campaign did not need to destroy German factories. It only needed to disrupt them enough to prevent Germany from closing the production gap. Comprehensively. By 1945, German tank production collapsed. The factories still existed, but raw materials were not arriving. The Ruhr industrial region was surrounded by Allied forces. Coal mines were in Allied hands. Iron ore shipments from Sweden had stopped. Oil refineries that produced gasoline were destroyed. In January 1945, Germany produced 900 tanks. In February, 700. In March, 500. By April, production had ceased completely. The factories were captured or isolated behind Allied lines. Workers were fleeing westward as Soviet forces advanced. The machinery was intact, but nothing was moving. American tank production in April 1945 remained above 1,000 Shermans per month, despite the fact that Germany was clearly defeated and the war in Europe would end within weeks. American factories kept building tanks until the government explicitly ordered production to stop. When production finally halted, in May 1945, the United States had produced 49,234 M4 Sherman tanks in 3 years and 3 months. 49,234. The number is difficult to comprehend. If those tanks were lined up end to end, they would stretch from New York to Los Angeles. If they were parked side by side, they would cover over 40 square miles. The combined weight of all Shermans produced exceeded 1,400,000 tons, more than the total tonnage of the Japanese Navy at the start of the war. The production required approximately 490 million pounds of armor plate, 196 million pounds of cast armor, 740 million pounds of rolled steel. It consumed enough rubber for 500 million tires. It required wiring that would circle the Earth 8 times. Building those tanks employed hundreds of thousands of workers across dozens of factories in 11 states. The workers operated in facilities that had been retooled from peacetime production in less than a year. Most learned their jobs in weeks. They built tanks that were mechanically reliable, tactically adequate, and available in numbers that overwhelmed all opposition. Germany produced approximately 25,000 tanks of all types during the war. That included Panzer II's, Panzer IV's, Panthers, Tigers, assault guns, and tank destroyers. America produced almost twice as many Shermans alone as Germany produced total armoured vehicles. The Soviet Union produced over 60,000 T-34 seconds. Britain produced approximately 27,000 tanks of all types. Total Allied tank production exceeded 160,000 vehicles. Total Axis tank production was approximately 45,000 vehicles, including all German, Italian, and Japanese tanks. Allied production exceeded Axis production by a ratio of more than 3-to-1, and the Sherman alone represented 30% of all Allied tank production. These numbers meant that by mid-1944, German tank commanders faced a battlefield reality where American armor was effectively infinite. A German Panzer company might destroy every Sherman it encountered in a battle and then face a fresh American tank battalion the next day. The Shermans were not individually superior. German tanks had better guns, better armor, better optics. But German tanks existed in numbers that could be counted and tracked. The Americans had so many Shermans that German intelligence stopped trying to maintain accurate counts. Reports simply noted that American armoured strength was sufficient for sustained operations, which was military terminology, meaning the Americans had more tanks than Germany could destroy. Heinz Guderian, the general who had stared at impossible production numbers in July 1943 and concluded they were errors, commanded all German panzer forces on the Eastern Front from March 1943 to February 1944. He was then recalled to Berlin and appointed Inspector General of Armoured Forces, responsible for organising and training panzer divisions. His mandate was to rebuild German armoured strength after catastrophic losses in Russia. He visited factories, reviewed production schedules, calculated replacement rates, and compared them to loss rates. The mathematics were unambiguous. Germany was losing the production war by margins that could not be overcome. In February 1945, with Soviet armies approaching Berlin and American armies crossing the Rhine, Guderian presented his analysis to Adolf Hitler. He explained that German armoured forces had been effectively destroyed by attrition. Losses exceeded production by 3-to-1. The gap was widening. Germany no longer had the industrial capacity to field armoured forces capable of stopping Allied advances. Hitler dismissed the analysis. He blamed traitors, cowards, defeatism, anything, except the fundamental reality that Germany could not match Allied industrial production. Hitler still believed that German tactical superiority and fighting spirit could overcome material disadvantages. He still believed that superior German tanks crewed by elite soldiers would prevail over numerically superior but inferior enemy tanks. He still believed that one German panzer was worth 5 Allied tanks. He was wrong. One German panzer was worth 5 Allied tanks in isolated engagements, but Germany produced one panzer for every 25 Allied tanks. The ratio was insurmountable. Guderian knew this. Every panzer commander knew this. By early 1945, every German soldier knew this. They fought on because they had no choice, not because they believed victory was possible. The Sherman tank was not the best tank of World War II by most technical measures. The German Panther had a better gun, better armour, better mobility. The Soviet T-34 had better sloped armour and better cross-country performance in winter conditions. The British Churchill had better armour protection. The Sherman's gun was adequate, but not exceptional. Its armour was decent, but not outstanding. Its mechanical reliability was good, but not perfect. What made the Sherman decisive was not technical superiority, but sheer overwhelming numbers. American industry produced Shermans faster than German forces could destroy them. That production capability, more than any battlefield innovation or tactical doctrine, determined the outcome of armoured warfare in World War II. The lesson was not lost on post-war military planners. Industrial capacity matters more than technical superiority. Adequate equipment available in overwhelming quantities defeats superior equipment available in limited quantities. The Sherman proved this principle comprehensively. German tanks were better. German tactics were better. German crews were more experienced. None of it mattered because Germany could not produce enough tanks to replace losses. By the time German commanders accepted that American production numbers were real and not propaganda, it was too late to matter. The production gap was unbridgeable. Germany could not build enough factories, train enough workers, or secure enough raw materials to match American output. The war was decided in factories in Detroit, Lima, and Grand Blanc, not on battlefields in France and Germany. American industrial planners understood this from the beginning. In December 1941, immediately after Pearl Harbor, the War Production Board projected that America would need to produce at least 50,000 tanks to win the war. That projection assumed heavy losses, extended combat operations, and simultaneous campaigns in Europe and the Pacific. The projection was accurate. America produced approximately 88,000 tanks of all types by the end of the war, including 49,000 Shermans. The excess capacity beyond 50,000 tanks provided reserves, Lend-Lease deliveries to Allies, and replacement stocks that ensured American armoured units never lacked equipment. German planners never made equivalent projections because they never imagined the war would require production at that scale. They planned to win quickly using existing forces augmented by modest production increases. When the quick victory failed to materialize, Germany lacked the industrial infrastructure to pivot to mass production warfare. The Sherman's production story is not primarily about tank design. It is about industrial systems, manufacturing processes, logistics, training, and organizational capacity. It is about American factories that retooled from peacetime production to wartime production in months. It is about workers who learned to build tanks in weeks. It is about designers who prioritized manufacturability over technical refinement. It is about a production system that could build adequate equipment in overwhelming quantities faster than enemies could destroy it. The Sherman was not a perfect tank. It was a sufficient tank built in numbers that made its imperfections irrelevant. German tank commanders who spent 3 years fighting Shermans learned to respect them not because they feared individual Shermans, but because they understood that destroying one Sherman meant nothing when 3 more would arrive tomorrow. That psychological weight, knowing that no matter how many enemy tanks you destroyed, more would appear, was devastating to German morale. By late 1944, experienced German panzer crews reported feeling overwhelmed even in engagements they won tactically. You could destroy 5 enemy tanks and still be forced to retreat because 20 more were approaching. You could achieve a 10-to-1 kill ratio and still lose ground because the enemy could afford 10-to-1 losses indefinitely. The mathematics of attrition were inescapable. Kurt Meyer, commander of the 12th SS Panzer, division in Normandy, described fighting American armored forces as attempting to hold back a flood. You could build walls, dig channels, create barriers, but the water kept rising. Eventually, the walls were overtopped not because they were poorly built, but because there was too much water. The Sherman was that flood. 49,234 tanks rolling off American production lines between 1942 and 1945. 49,000 Shermans, plus 39,000 other American tanks, plus 60,000 Soviet T-34 seconds, plus 27,000 British tanks. The combined Allied tank production created an armoured force so large that Axis powers could not physically destroy it fast enough to prevent their own defeat. That was American industrial power in World War II. Not superior individual weapons, but adequate weapons in numbers that overwhelmed all opposition. The Sherman proved that industrial capacity wins wars. Technical superiority wins battles. But battles mean nothing if you cannot sustain the attrition long enough to win the war. Germany won countless battles and lost the war because they could not replace their losses. America lost numerous battles and won the war because their factories kept producing replacement equipment faster than it could be destroyed. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.